All right, let's talk about something fascinating. How do machines actually learn? Today, we're going to crack open that black box and look at the two main ways they do it. And you know what? You might be surprised at how familiar it all sounds. Ready? Let's get into it. So, let's start right there. How does a computer go from being, just a box of circuits to making smart predictions? Well, in a lot of ways, it's not all that different from how we learn. I mean, think about it. Sometimes you learn with a teacher guiding you, right? And other times, you're just kind of thrown in and have to figure things out on your own. And that's pretty much the perfect way to think about this. On one hand, you have learning with an answer key. It's like studying for a test when you already have all the solutions. And on the other hand, you're plain detective, trying to piece together clues without any help. Let's dig into that first one, the one with the answer key. So this learning with a teacher approach, it has a formal name. Supervised learning. And the name really says it all, doesn't it? The whole process is supervised because you start by knowing all the right answers. The absolute key, the secret ingredient here, is something called labeled data. All that means is that for every example you give the machine, you also give it the correct answer. The whole point is for the machine to learn the patterns so well that it can eventually start making its own accurate predictions on stuff it's never seen before. So where do you see this in real life? Well, it's everywhere. Think about predicting a house price. You feed a computer thousands of house listings with their final sale prices. It chews on that data, learns the patterns, and pretty soon it can guess the price of a brand new house. Or even simpler, your email spam filter. It learned what spam looks like by analyzing millions of emails that people like you already marked as spam. See? It all starts with having the answers. Now, this supervised method is really good at two main things. First, there's classification. That's all about sorting things into buckets. Is this email spam or not spam? Is this transaction fraud or not fraud? The other one is regression, and that's for predicting an actual number, like what will the stock price be tomorrow, or how many inches of rain will we get? Different goals for sure, but they both start with that all-important labeled data. Okay, but what happens when you don't have that answer key? What if you're just given a giant pile of data and someone says, go find something interesting? Well, that's where we get into the world of unsupervised learning. I like to call it exploring without a map. This is that detective work we were talking about earlier. With unsupervised learning, the model gets nothing but raw, unlabeled data. No hints, no correct answers. Its entire job is to just dive into that messy data and find the hidden structures, the natural groups, the interesting patterns, all by itself. A perfect example of this is something called customer segmentation. So imagine a big online store. They've got tons of data on their customers, what they buy, when they shop, how much they spend, but they don't have any predefined groups. So they can use an unsupervised model to sift through everything and, poof, it discovers natural clusters on its own, like bargain hunters, or loyal weekly shoppers, or people who only buy gifts. The machine finds those groups without any human help. Pretty cool, right? And this detective work can have a few different missions. Clustering is exactly what we just talked about, grouping similar things together. Then there's dimensionality reduction, which is just a really fancy way of saying simplify the data by finding the most important bits. And then there's association, which is all about finding hidden relationships. Like how supermarkets figured out that people who buy diapers are also very likely to buy beer. It finds the connections you never even knew to look for. Okay, so we've met the teacher and we've met the detective. Now let's put them right next to each other, because this is where it all clicks into place. I mean, look at that. The difference is crystal clear when you see it like this. Supervised learning needs labeled data because its goal is to predict an answer we already know how to define. But unsupervised learning uses unlabeled data because its whole mission is to discover some new hidden structure. One is about prediction, the other is about exploration. And that brings us right back to where we started. It really is that simple. Supervised learning is the student with the answer key and the teacher. Unsupervised learning is the detective on a brand new case with no answers in sight. One has a guide, the other is on its own. So really, if you're going to remember just one thing from all of this, let it be this. The huge, game-changing difference between supervised and unsupervised learning isn't the complex math or the fancy algorithms. Nope, it's all about the data you start with. And here it is, plain and simple. Labeled data has the right answer already attached. This is a picture of a cat, this house sold for this much. Unlabeled data is it's just a bunch of raw information with no answers attached. And that one little difference changes everything. And that really brings us to the final thought here. From the movies Netflix recommends to you to the way your photos get organized on your phone, both of these learning methods are quietly shaping your world every single day. So I'll leave you with this question to chew on. Which one do you think has a bigger impact on your life? Something to think about. Thanks for digging into this.